Hello and welcome to South Junior Math. Today we are going to be looking at number base. But first thing first, what is number base? Number base is defined as a system of counting in which certain units make up a bundle, and this bundle forms the basis of place value. Now, I want us to realize that base 10 is the most generally accepted way of counting. Now you may ask me that why is base 10 the general form or the most acceptable form of counting? The answer to that question is very simple. It's just because of the way we are being created. We are being created with 10 fingers, and from the days of our forefathers, it has been realized that counting with the 10 fingers has been convenient and easy. And that is what brought about the basis of base 10 counting, or that has brought the basis of what? Of counting in base 10. However, we have other base systems, like we have base 2, we have base 16, we have base 60 and the likes. There are selected base numbers or number base that are, can I say, that are well applicable or that can be used in this world we find ourselves. So now the next question is, what happens if we are in this world and we are created with 2 fingers? What do you think may happen? Well, I believe you've guessed right. It means that our most acceptable way of counting may be in base 2. However, it's just because we are being born with 10 fingers. That is why we are what? We are counting in base 10. We have other base systems like what I've said earlier, like base 2. Base 2 can be used in the computer world, in electronics, digital electronics, and in the making of computers. Base 2 has been found to be very useful. So which means after base 10, base 2 happens to be the next number base that is very useful. We also have hexadecimal. Hexadecimal is in base 16 and is very useful and very functional when it comes to computer programming. We also have sexagesimal. Sexagesimal is in base 60 and it is very useful in terms of time measurement or when measuring time. So, our next question again is there an end to a number base? And the answer is no. There is no end to number base. Number base continues. The only difference here is just that some number base are more efficient and more useful than the other. You understand? So, and I can say we have base infinity, we have base 1000, we have base 100. It is just in theoretical form, but in its practical nature, they are less useful. So that is why some number base are being selected. And I want us to also realize that for every number base that is in base X, its digit is always 1 less than X. Let me take that again. For every number base that is represented as letter X, its digit that is formed is always 1 less than X. So we are going to be looking at the number base. We are going to look at different number bases here today. So we are going to be starting with base 10. Base 10 can also be called decimal or denary. Now, the digits that are being formed by base 10 are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, let's not forget I said something earlier. I said if the base number is X, the digit formed is always 1 less than X. What does it mean? It means X minus 1. So if the base is 10, then the digit it will form is going to be 10 minus 1, and that is 9. So which means the digit form is going to be from 0 to 9. And if you observe that this from 0 to 9 happens to be the unique numbers, in the sense that the moment I say 10, it means I'm repeating 1 and 0. The moment I mention 300, I'm picking up this 300. So there are no unique numbers aside 0 to 9. Please, let's take note of that. Then we have base 9. Base 9 can also be referred to as nonary. Nonary. And the digits is that is 0, 1, 2, 3, 4, 5, 6, 7, 8. We have base 8. Base 8 can also be called octal or octanary. And the digit it forms here is 0, 1, 2, 3, 4, 5, 6, 7. Then we have base 7. Base 7 can also be called septenary or septenary, and it's from 0, 1, 2, 3, 4, 5, 6. Then we have base 6, and base 6 can also be referred to as senary, and it is 0, 1, 2, 3, 4, 5. Then we have base 5. Base 5 is quinary, and it is 0, 1, 2, 3, 4. Then we have base 4. Base 4 can also be regarded as quaternary, and it is 0, 1, 2, 3. Then we have base 3. Base 3 can also be referred to as ternary, which is 0, 1, 2. Then we have base 2, which is binary, and that is 0, 1. Now, if you look at this, the way I arranged it, you will notice that for every base number that you find here, the digits formed are always 1 less than x, or one less than the base that you see here. So for base 10, we can see that we have a total of 9 digits. For base 9, we have a total of 8 digits, though by mere looking at it, it's starting from 0. So it's like saying 0, 1, 2, 3, 4, 5, 6, 7, 8. So by mere looking at this thing, it's by my fingers, it makes it look as if you are dealing with 9 digits. But in its actual sense, when you write it out, it's always what? 1 digit less than the base number. So this is base 8. 0, 1, 2, 3, 4, 5, 6, 7. Base 7, 0, 1, 2, 3, 4, 5, 6. So for every number that you find here in front of every base, you will see that the digit it's formed is always 1 less than the number you have here. So as you can see, from base 2 down to base 10. Now, having known that, then we now proceed by understanding how our place value is formed. Now let's set an example. Before then, I want us to also note something, that base 10 system of counting has always been what we have been used to right from when we were kids. You see, when we were in primary school, kindergarten, the counting of numbers 1 to 100 to 1,000 to 10,000 and the likes, the addition, subtraction, multiplication, and division of numbers that we have been doing right from when we were kids till this very moment has always been in base 10. So now let's quickly look at how these place values are being formed. Now let's start an example. Let's say we have 1, 2, 3, 4, and it is in base 10. Yes, and there's something I want us to understand, that to avoid confusion, please don't form the habit of writing base 10 using numbers. Instead, form the habit of what? Of writing them in words. Please take note that anytime you're writing the base number, always write them in words. not in number. So now let's proceed. Now let's look at this question. You are told to expand these figures. So this is 1,000, or let me say 3. Let's say 3,234. So 3,000. So if I want to start, I can just say this is 3,200, 3 tenths, and 4 units. 3,200, 3 tenths, and 4 units. And let's not forget that in our primary days, you always see something like unit, tenths, hundred, thousand. So let's quickly analyze and see the reasons why it's always like this. Now, let's not forget that this is in base 10. So this 3,000 can mean 3,200, 3 tenths, 4 units. Now, let's break it down. So I can as well say, let me put this there. So I can as well say this 3,000 can be broken down to 3 times 1,000 plus 2 times 100 plus 3 times 10 plus 4 times 1. So what does this mean? This means that I can as well say this is 3 times 10 raised to power 3 plus 2 times 10 raised to power 2 plus 3 times 10 raised to power 1 plus 4 times 10 raised to power 0. Please let's not forget that anything raised to power 0 is 1. Please let's not forget that any number raised to power 0 is 1. I've explained that explicitly in one of my videos on indices. Please, you can always check it there to understand why. So we have 3 times 10 raised to power 3 plus 2 times 10 raised to power 2 plus 3 times 10 raised to power 1 plus 4 times 10 raised to power 0. What do you observe? You have observed or seen here that the figures from our right hand side to the left hand side is increasing 0, 1, 2, 3. And because of we are dealing with base 10, that is why you can see 10, 10, 10, 10. So that's by the way. So what happens if you are given another question like maybe 1, 2, 3 in base, let's say base 5. Let's choose another number base. Now, the way I called 3,234 easily, I won't say this is 123. No, it's wrong. Because this is not in base 10. If it were to be in base 10, I would have called it normally. But because this is in a different base, instead I will just say 1, 2, 3 base 5. I won't say 123 base 5. Instead I will say what? 1, 2, 3 base 5. Why? Because we have gotten to another word of number base, which is base 5. So how do we break this down? So I can as well say this is like saying 125, comma, 2 fives, and 3 units. 125, 2 fives, 3 units. If I want to call it just the way I called 3,200, 3 tenths, and 4 units. So if it's in the word of base 5, I will say 125, 2 fives, 3 units. So what does it mean? It means, so this one I will say 1 times 25 plus 2 times 5 plus 3 times 1. Look at it again. 1 times 25 plus 2 times 5 plus 3 times 1. And I can as well say this is 1 times 5 raised to power 2 plus 2 times 5 raised to power 1 plus 3 times 5 raised to power 0. Let's not forget that because of we are dealing with this base 5, that is why you see it in this manner. Because we were dealing with base 10, that is why you see me ending up with this figure. And if you observe, you will see that it is rising from 0, 1, 2. So the way I wrote my unit tens, 100,000 is going to be the same fashion but in a different dimension. So this is it. 1 times 5 raised to power 2 plus 2 times 5 raised to power 1 plus 3 times 5 raised to power 0. And that is how we'll keep trying different kinds of numbers in their respective place value. I hope you've understood or gotten one or two things from here. Thank you very much. And I will be very glad if you can please subscribe and share to your friends. Thank you as always. See you in my next video.